Hi guys, it's Alex. Today I'll talk with Rae, who is science writer for the SENS Research Foundation. We'll talk about the SENS Research Foundation, anti-aging research, anti-aging therapy, and some other SENS activities. On 23rd of June, SENS Research Foundation had grand opening of their brand new research center. I'm gonna show you a short demo video about that. Then will be Michael's intro, and after that our conversation. The link on the SENS Research Foundation website will be below the video in the description section. And now guys, let's go!
Rae. I've been with SRF since there was an SRF back in 2009, and before that I was actually with the precursor of SRF when we were embedded inside the Methuselah Foundation. So I am a science writer for SENS Research Foundation. I wear a lot of different hats. I do a lot of our external communications to the public to translate what kind of science we're doing to a general audience. I also do a lot of science technical briefings for our inside organization, and I participate in our research development committee where we decide what our key scientific priorities are and how we're going to award grants to new organizations that are proposing new rejuvenation biotechnology research. Aging really is the medical problem. It is the cause of 110,000 people's deaths every single day. It is the predominant cause of death worldwide, now even in developing countries. It also causes just an enormous amount of suffering. The so-called diseases of aging, if we're looking at Alzheimer's or cardiovascular disease or cancer, those are all just particular manifestations of the aging process. We really have to tackle aging head-on instead of trying to attack these individual diseases one by one, which is a really failed approach. I think I've always really recognized that the ways that people accommodate themselves to aging and death are sort of nice stories that don't really help us very much. I think it only became something I was aware of in the 1990s that there were actually scientists working on the idea of intervening in aging and developing therapies against aging, and maybe there are things we could already do against aging. And that just immediately captivated and excited me. And the more I followed that thread, the more I got into the core science that eventually led me to Dr. DeGray and the damage repair approach, which is the really iterable way that we can ultimately conquer aging as a process of disease and debility in human beings. So, liberating us all from the specter of the idea that all of us and all of our loved ones are on a declining path from the time we reach a so-called peak in our 20s is just going to open up so much limitless human potential and just so much relief from this specter hanging over us through our lives. It will be a truly re-envisioned humanity that is just an inescapable vision. Our donors are, of course, the core of everything that we're doing. Science costs money. It's an expensive endeavor. It costs money to keep our science fed and housed, and it costs money to keep our scientists in all the reagents they need, to keep our lab mice alive, to do everything that we're doing. And there is just no way to do that without funding. And especially in the early years to get us going, it was just critical to have money that was independent of the very narrow vision of the National Health Institutes of Health and other funding sources. And now to be able to do really radical work that is still not recognized within the NIH or conventional funding sources. There's nothing like, individual donors who are supporting the vision of a future free of aging and willing to gamble on really exciting, really breakthrough research to keep us going.
Hi, Michael. Thank you for joining today.
Happy to be with you. Yeah, we had a bit of logistical trouble getting her set up, but it all will go well from now on, hopefully.
Michael, please tell me about SENS Research Foundation. What should people know about SENS Research Foundation? And on 23rd of June, you had grand opening of your brand new research center with new extended facilities, new lab, new equipment. So tell me please about this as well. And could you tell me about guests who visited this amazing event?
Sure, yeah. So SENS Research Foundation is a biomedical research foundation, and our purpose is to develop therapies that will bring human aging to an end. So that means that the process whereby young, healthy people become progressively sicker and frailer over time, we're developing therapies that intervene in those processes so that people will remain young and healthy no matter how many years they crank onto their calendars. So if I look at you, Alex, I'm guessing you're like a 30 or 40-year-old man. You could be 130 or 230, and we would still be looking at you, and you would still look that way. You would still feel as good as you feel. You would be at similarly low risk of disease and death. That's the aim, right? So strategically, how do you do that? And that's where the first word in SENS Research Foundation comes from, SENS. That stands for Strategies for Engineered Negligible Senescence. And that's a mouthful, but what it means is it's an approach whereby we are looking at the cellular and molecular damage that accumulates in your cells over time and developing therapies that remove that damage. And so in biology, function follows form. And so when you have essential molecules and cells that are damaged, they can't do their role. And the more of that damage you accumulate, the less your tissues and organs can carry out their normal functions. And when they can't carry out their functions to a sufficient degree, that's what we call a disease, right? So Parkinson's disease is the accumulation of damage to things like the neurons in your brain that produce a messenger molecule called dopamine. And so we will have to develop cell therapies to replace those missing neurons. Another part of Parkinson's disease is the accumulation of damaged proteins in the brain based on a protein called alpha-synuclein. And those proteins get twisted up and bound together to each other, and that affects aspects of your movement and aspects of your sleep behavior. And so to develop therapies that will actually bind to and remove those damaged proteins from your brain and so forth. So the idea is we just go through all the different damage to your cells and biomolecules that accumulate in your aging body, and by removing and repairing and replacing that damage, we can restore the structure of your body to what it was when you were young, and that will keep you young and healthy indefinitely if we just keep doing it. So that's the SENS approach, and SENS Research Foundation is, again, a biomedical research therapy that is designed to develop therapies on that approach. And you asked about our grand reopening after our expansion. So yeah, So that was back in July, as you say. So we have been in the same location in Mountain View, California since 2011, and we have progressively sort of outgrown that as our research has expanded. So the original headquarters was 2,500 square feet, and we expanded that twice so that by 2014 we were about twice that size. And with this new addition that we just added in 2022 through 2023, we are now at a total of 1,200 square feet. So it's more than double what we started off at. And we've added a whole bunch of new equipment, which allows us to do things we weren't able to do before. And so it's more room for scientists and for equipment and tools that help our scientists do their job. And as far as who was there, well, we had a bunch of different kinds of people. So we had representatives from the city of Mountain View. So we had the mayor and the president of the local chamber of commerce and a couple of other representatives. We had our federal congresswoman and SUC Center representative, and we also had several state-level politicians and their representatives. So we had a whole bunch of people from sort of the broad political and cultural sphere, and we also, of course, had a lot of people who were working in rejuvenation biotechnology or were supporters of the work that we do. So we had a bunch of our board members come in from all over the world. We had Oki O'Connor, who used to be our vice president for research and has headed a rejuvenation biotechnology startup called Cyclarity. He came back to see us and celebrate with us. We had the president of the U.S. Transhumanist Party join us. We had a whole bunch of supporters and just people from all over the community come out to, just celebrate what we had done. They got to tour the lab. They got to see the new equipment, talk to our scientists. It was a lot of fun. Yeah.
Michael, so excited. Michael, what SENS Research Foundation works on new projects this year?
So there's a bunch of things. So there's a couple of things that we just finished up just recently. So you're probably aware, and some of your audience will be aware of this problem of senescent cells, right? So one of the kinds of damage that accumulates in the aging body is that we accumulate these cells that have undergone this change whereby they are no longer reproducing themselves and they are producing this harmful secretion profile called the SASP. And that releases a bunch of inflammatory factors and factors that damage the local tissues. And so removing those cells is an important target for therapies for rejuvenation biotechnology. And so one of the ways that SASP, those secretions that senescent cells produce, harm the body is the SASP factors actually will hit neighboring cells and turn them into senescent cells. So it's kind of a domino effect. And one of our scientists, Dr. Testvan Desale, discovered that those secondary senescent cells, so the cells that get turned senescent by the SASP from the first senescent cell, they actually are resistant to most of the drugs that have been so far tried experimentally to destroy senescent cells. So there was a whole class of senescent cells that we were not going to be able to hit. And he was able to discover that the abnormal iron metabolism that senescent cells undergo makes them vulnerable to a new kind of senolytic drug. And he discovered that using a kind of a smart bomb that is only activated when it enters into senescent cells, he was able to destroy both primary senescent cells and the secondary senescent cells both. So that just recently was published. That was a really exciting piece of work. We are also just about to publish, having moved some of our mitochondrial therapies into mice. So another kind of damage that accumulates in the aging body is that a subset of our cells accumulate these large deletion mutations in their mitochondrial genome. So the mitochondria, as a lot of people will know, are the energy-producing organelles in our cells. And when they generate energy, they also produce a toxic byproduct. And that toxic byproduct sometimes damages the genome that mitochondria have. And some of those mutations that are caused by that can be eliminated and the mitochondria can be replaced, but these large deletions can't be eliminated and replaced, and unfortunately they actually take over the cell entirely. And so we have an approach to deal with that, and for the first time we were able to move one of those therapies into mice. So we have mice that have an inborn mutation of the kind that we need to replace, and using this gene therapy, we can safely produce the proteins that those genes produce and send them into the mitochondria to restore normal mitochondrial function in these mice. So that is really exciting. We're hoping to publish that soon. In terms of really new projects that we are still working on right now, there's a few. So one is there is a different senolytic approach that another scientist in our lab is working on. Her name is Anna Barkovskaya. I believe she's actually a countryman of yours. She's Ukrainian. And she has a completely new senolytic strategy that is so new I can't even tell you what it is yet, but it is looking very promising. And so they're working on that right now. Another thing that we're working on that I can't quite tell you about yet, one of the ways that the body defends itself against senescent cells is it sends immune cells to remove senescent cells after they have done their job. And it was known that several kinds of cells are involved in removing senescent cells, and the best understood of those was a cell called a natural killer cell. But although those were really well demonstrated in experimental systems, it wasn't clear that any of them were actually responsible for removing senescent cells the way they accumulate during aging. And one of our scientists, Dr. Amit Sharma, has discovered now really good evidence that there is a different kind of cell type from the immune system that no one had even been looking at that actually is much more effective than natural killer cells at destroying senescent cells. And it has the advantage in terms of developing therapies. This cell type is just a lot easier to harness using biotechnological methods. So that is really exciting work that they are working on right now. Also, our mitochondrial team is working on two different approaches to deal with the mitochondrial deletion problem that we hadn't previously considered, one of which is a way to eliminate mitochondria that have these damaged genes inside of them and replace them entirely rather than trying to substitute for the genes as we have been doing previously. And another approach is to allow the body for the first time to successfully cull the damaged mitochondria itself by removing the cloaking, as it were, that these mitochondria have that shields them from the normal maintenance systems that would otherwise get rid of them. So all those projects are ongoing right now.
Wow, amazing. Michael, you have inside information about trials, researches. In your point of view, when will appear the first really effective anti-aging technology?
So this is actually a trick question because there actually is a really effective anti-aging technology that has been licensed, approved, and is being given to patients right now. I mentioned a little bit earlier in a different context, one of the targets that we have to go after to develop a comprehensive therapy against aging is the removal of damaged proteins from the body. And one of the best known of these damaged proteins is called beta amyloid. Beta amyloid accumulates in the brain and it drives cognitive decline with age. It's particularly important in Alzheimer's disease. And over the course of the last 6 months, we've had 2 approvals and 1 phase 3 clinical trial that's been published that is expected to lead to an approval very soon, all of which are antibodies that remove these proteins in the brain and have been shown to substantially slow the decline of cognitive function in people who already have what is called mild cognitive impairment, which is kind of a stupid name because mild cognitive impairment is not mild at all. It's actually pretty severe, but it's not yet full-blown dementia. And so when they give these antibodies to people who have mild cognitive impairment or even the earliest stages of dementia, they can slow down their progression into full-on and worsening dementia quite a bit. And And so that's an important thing to understand about SENS approaches is it's not like you have one pill that cures everything, right? You have to target each and every one of the different kinds of damage and remove them or replace them or repair them. And so it's not as if by removing this one protein we have solved all of aging, but it is one of the different kinds of things we're going to have to do to solve aging. So as I say, like when you say, when will there be one? Well, there already is one, and there's going to be more soon. If you were to ask me what is the next therapy that I expect to be available, I would suspect it's one of two. So there are several clinical trials on right now for using a technology called induced pluripotent stem cells. So this is a way whereby I can take a cell from the deep layer of your skin and I can wind back its developmental clock so that it can turn into something different. And in this case, what they do is they give it chemical cues that wind it forward and turn it into a dopamine-producing neuron. Now, you might remember earlier on, I mentioned that the loss of dopamine-producing neurons in the brain is one of the important lesions that cause Parkinson's disease. So there are two clinical trials on right now whereby scientists are doing exactly that. They're taking patients' cells out of their deep layers of their skin, they're turning them into these dopamine-producing neurons, and they are going to implant them into the brain of people with Parkinson's disease and see if they can restore or stop the progression of their Parkinson's disease doing that. There was another case that a phase 1 trial was actually published just a few weeks ago by a company called Blue Rock Therapeutics, where they are using a similar technology derived from embryonic stem cells, and they're doing the same thing. So between one of those three, I expect that a cell therapy based on stem cells for people with Parkinson's disease is going to be quite possibly the next. The other possibility is one or another of these drugs that destroy senescent cells we were talking about earlier might be licensed. The one that is most advanced right now, there's a company called Unity Biotechnology, and they just had a very successful phase 2A trial where they showed what people with diabetic macular edema, so this is a kind of damage that accumulates in the eyes of people with diabetes and causes vision loss, they were able to improve the vision in these people by destroying senescent cells inside their eyes. So that could be approved quite quickly as well. So yeah, so there's a couple of them that are already licensed and a few that are likely to be out there fairly soon.
Michael, you already mentioned, but where do you expect SENS Research Foundation will have breakthrough in anti-aging therapy? It's what you mentioned, what you talked about, yeah?
Yeah. So it's happening all the time, right? It's not going to be that there's going to be one cure for aging and boom, we're done, right? It is going to be progressively, we are going to target each and every one of these different cellular molecular lesions and develop different ways to remove, repair, or replace them or render them harmless by one way or another. And so progressively, we're going to get all these things underway. I've only just mentioned a few. There's lots of other kinds of research that are ongoing right now that are going to progressively tackle more and more of these different kinds of damage. And that's how we are eventually going to first get aging under really good control and then progressively push it further and further back until we have it under complete control and can get to that vision I was mentioning earlier where, I could look at a person like you and see that you're in pretty good health, that you look young, that you're able to exercise, but you could be 240 or 830 and no one would know the difference.
Yeah. Michael, does SENS Research Foundation has already clear understanding which methods and approaches don't work for anti-aging therapy?
Yeah, there's quite I mean, the world is full of many kinds of things that don't work as anti-aging therapies. Of course, people have been trying to develop therapies against aging for literally thousands of years. As an example, in ancient China, people developed so-called anti-aging elixirs that included mercury. which obviously was not a good anti-aging therapy. Some of the things, though, that today have gotten a lot of hype and that I am very confident do not work. One is a dietary supplement called resveratrol. That got a lot of excitement when it partially normalized the very short life of animals that had been fed these extremely high-fat, extremely high-sugar diets and became just severely obese and actually tended to cause damage to their lungs. And resveratrol, partially fixed the problem in these severely obese mice. And people said, wow, it's an effective anti-aging therapy. And no, of course, when they finally got around to testing resveratrol in normal mice and rats, it had no effect at all on their lifespan. It did seem to improve at least a couple of aspects of their health, but not enough to actually make them live any longer. Another one that has gotten excitement, mostly again based on experiments in short-lived abnormal mice, is a drug called metformin. Metformin is normally used for diabetes and has gotten a lot of excitement as a potential anti-aging therapy. I actually did a 5-part blog post explaining why the research suggesting that metformin was going to be an effective anti-aging therapy were all sort of not really based on good science. And I'm actually going to be, in the next somewhere between month and 2 months, going to publish another in that series, because there's been 2 important new papers that have been published that once again show that no, there just is no such effect. This is not going to work. So yeah, but again, like the world is full of so-called anti-aging therapies that do nothing at all, or that even in some cases are harmful.
Michael, in the SENS Research Foundation, your team makes lots of different trials. When will created anti-aging cure? Will we have to take it one time each year or every 5, 10 years? Because you do it on mice, isn't it? I expect you know.
Yeah. Well, of course, you always do it in mice first. It's part of the process. So going back to what we were talking about a moment ago, where we're not going to develop one cure that cures all of aging. We are going to target each of the different kinds of cellular and molecular damage that accumulate in the aging body. It's really just going to depend from one therapy to another how often you have to administer it. So you would probably expect that, for instance, if we develop these backup copies for the genes that become deleted in mitochondria as we age, that might all be able to be done sort of once permanently, and you'd never have to deal with it again. Whereas senolytic drugs, you might have to take, a course of them, say, every year. The removal of beta amyloid proteins, you might have to do that every 5 years. I'm kind of making this up because we won't really know until we get to humans, but you would expect that because different kinds of damage accumulate at different rates and different therapies are going to have different, abilities to remove damage, whether they can only remove a little bit at a time or remove a whole bunch all at once, it's just going to be different schedules. In the phase 3 clinical trials for the beta amyloid therapy, as I was mentioning earlier, they actually had to go in, I believe it was once a month for 6 months and get an infusion over and over and over again to clear it out of their brain, and then they just stopped. But nobody expects that that's going to be forever. You expect that they're going to continue accumulating beta amyloid again, and so sooner or later you're going to have to send them back in for another round of therapy. So it's just going to depend from one therapy to another, how often you have to go in and how intensely do you have to apply it.
Michael, rejuvenation technologies will affect whole organism or only some organs and tissues which we have over 220?
So this again goes back to what we were just saying a moment ago in terms of like you're targeting different kinds of damage. And of course, different kinds of damage accumulate differently in different tissues, right? So I mentioned beta amyloid. That's overwhelmingly in the brain. You see a little bit of beta amyloid actually in the muscle, but by and large, you don't have beta amyloid, say, in the liver or in your pancreas, right? So it's not going to affect that at all. Whereas something like senescent cells, well, you accumulate senescent cells in all of your aging tissues, so you're going to be removing senescent cells all over your body, although it might be that some senolytic approaches are better suited to different organs or tissues because, they have better pharmacokinetic access to different tissues and so forth. But in terms of the overall program, like we're going to rejuvenate the whole body, right? We are not going to rejuvenate everything except your pancreas or rejuvenate everything except your lungs. We're going to rejuvenate everything. It's just going to be different therapies are going to target different kinds of damage that are differentially present in different tissues.
Michael, what main problem experience SENS Research Foundation?
I mean, the biggest problem we experience is just we don't have enough funding, right? I mean, aging is a horrendous problem, and there's just a lot of biotechnological work to do, and there's no lack of ideas, right? There's all kinds of experiments we would like to be doing if we had the money. And so our funding has gone up and down, but it has never been as high where we would say, like, yes, we don't need any more funding, thanks. We're doing just fine now. We got aging under control. So yeah, our biggest problem by far is money. The second biggest problem is recruiting enough people, although that is also in part a function of money, right? If you have enough money, you can recruit people, but there is a shortage of scientists right now, so it is a problem.
Michael, could you tell me about something about your donors, sponsors, investors? How do you convince them to donate and invest? And how can someone become your investor or just to donate?
So let's divide donation and investing. So donating. Those are philanthropic donations. So people have to want, obviously, to. Well, actually, let me take a step back. So there are some people who want to get involved in aging because they see aging as a problem. They see the whole process of aging as a problem. They see our lives being short-lived because of aging as a problem, and that's what motivates them. There's other people who first get involved because they are very concerned about one specific disease of aging, and they come to understand that that is driven by aging processes. So there are people who first come in because of Alzheimer's disease or cardiovascular disease, or we had one major donor who got involved because of macular degeneration. Basically it's all about health, but it's what aspects of health are concerned about them. And so we talk to people about, why the damage repair approach is the best way to deal with aging rather than sort of the conventional disease by disease approach or the older approach that people tried to deal with aging and that a lot of people are still trying to deal with aging, which is to change the body's metabolism so that it inflicts less damage on itself rather than repairing the damage as it happens, right? Investing is a somewhat different problem. So you can't actually invest directly in SENS Research Foundation. We are a biomedical research charity. We don't take investments. But we do spin out companies once our therapeutic research becomes advanced enough. So I mentioned one of them earlier in the interview, Clarity. This is a rejuvenation biotechnology that we developed whereby these molecules that are based on carbohydrates become basically molecular scoops, and they have an affinity for a damaged form of cholesterol that is involved in atherosclerosis called 7-ketocholesterol. And what it appears that these molecules do is they go into cells and they capture 7-ketocholesterol and either exfiltrate it from inside the cell or bind to it in the membrane of the cell and remove it from there. So when we got that mature enough, we spun that out into a company, and it's the company in which people make an investment. And again, there's some people who invest in that because they're specifically concerned about cardiovascular disease, because that's what Clarity is going after. There are some people who invest in it because they really want a cure for aging as such. And so they see this as part of that, and they want to invest in it for that reason. And there's some people who just want to make money, and they see it as a good opportunity to do an investment.
Right.
So, different people, you talk to them in different ways. And of course, once it's spun out as a company, most of the investment research, the investment arguments are being made by the company rather than by us. But we're definitely cheering them on because, we want to see the therapies we develop win.
Michael, in your perspective, what global consequences will we have if mankind will go against nature of human beings and significantly slow down aging and extend lifespan?
So I will first take issue with the idea that we are going against nature, right? So if I give you a statin and that prevents you from developing cardiovascular disease during the course of what is currently a normal lifespan, no one thinks you're going against nature, even though I have changed the way your body works and I have held off disease and I have held off death. And that's all we're doing. We are removing damage from your body, holding off disease, and holding off death. I don't really see that as going against nature, or contrary-wise, if you see that as going against nature, well, antibiotics is going against nature. Lowering cholesterol is going against nature. Developing mRNA vaccines is going against nature. I don't think anyone really has a problem against going against nature if that's what going against nature means. So putting that aside, in terms of what are the social effects, so there's going to be a mixture of effects, and I don't know we can predict them all because it's going to be, such a dramatic change in human history. So one thing is people will be able to, obviously live longer lives and be healthier, and that's going to really change the economy because right now the economy is very centered around the idea that people are going to live for a limited amount of time, and then they're going to become progressively more disabled and unable to do their job and retire, and they will get replaced by other people. And so the economy is going to have to change to accommodate the fact that people are going to stay young and healthy, and some of those people are going to want to keep doing their job. We're going to probably have some effect on the human population, so we're going to have to adjust for that. The economy should become much larger because there's going to be more people being productive and fewer people being taken away by loss of productivity because they're taking care of other people because their parents are aging and they have to take time off work. So all kinds of things will change. Some of those changes will be good. Some of those changes will be difficult. I can only tell you that, whatever they are, good or bad, they are definitely going to be improvement over 110,000 people dying every day and several times that number getting sicker and sicker every day that they live. It's going to be a big change, but it's overall going to be a big change for the better.
Michael, cure from aging also can be cure from cancer.
So I'll say again that there isn't going to be a cure for aging, right? We are going to, through different means, remove different aspects of aging damage in the body, but the aging process is always going to be happening. We're just going to be always fixing it and thereby keeping ahead of it. And so one kind of damage that accumulates in the aging body is cells that bear mutations in their nucleus and that replicate out of control. That's what cancer is. And so it is an essential part of developing a comprehensive treatment set for aging that we deal with, cancerous cells. And so it is part of what we're doing to, develop a body that is invulnerable to cancer. So it's not like there's a cure for aging and that's going to cure cancer. There's a bunch of things we have to do to eliminate age-related health problems, and one of those is deal with cancer, if that makes sense.
Michael, question about China. You talked already about China, but I know that some members of your team have been to Hong Kong. You guys made research about Chinese anti-aging industry technology, about Chinese anti-aging therapy. Some of the hospitals already offer rejuvenation therapy for their clients. Michael, do Chinese really made a breakthrough in the anti-aging therapy? And do they really stay ahead of us in genetic engineering? What can you say?
So they're certainly making a lot of progress in genetic engineering in agriculture. As far as I can see, they are not making very much progress at all in rejuvenation biotechnology and anti-aging. As far as I can see, there are clinics in Hong Kong and a few in a couple other Chinese cities that are offering sort of what is hypothesized right now to be anti-aging therapies. So things like plasma transfusions and the drug rapamycin and the drug metformin, but nothing that you wouldn't see in, anti-aging clinics in Europe or the United States, and certainly nothing that is, clearly dramatically effective against aging, and really nothing that is actually in the repair-based approach that SENS Research Foundation favors. It's more in the change your metabolism in ways that causes your body to inflict less damage on itself and thereby slow aging. And we don't really even know that any of this stuff works in humans yet. We only really know that it works in mice because none of it's gone through phase 3 clinical trials for aging. So,
Michael, what's your message to people?
My message is that aging is an awful degenerative process that is killing people and robbing our health, and that is not a mysterious, magical process that just happens because of a law of nature. It is a medical process that happens just like any other medical process that causes people ill health, and that SENS Research Foundation has the best strategy for developing therapies that will eliminate the consequences of aging and thereby keep us young and healthy forever. And so we need everybody's support.
Michael, thank you so much for this fascinating and informative conversation. Thank you for being my guest today.
It's been good talking with you, Alex, and your audience.